Okay, so this is our second day of review for Chapter 8. So we're going to go through 8.1, 2, 3, and 4, reviewing fairly quickly. I'm going to hit the big ideas, and then we'll be working on student journal extra practice after that. So first of all, similar polygons 8.1 is almost exactly the same as 4.5, meaning from the dilations. So the similarity is the same scale factor. It's defined as the image over the pre-image. And that's if and only if you have a similarity transformation. So if you can map one figure onto the other figure with that scale factor, then you have similarity. Remember, if your scale factor is greater than 1, it is an enlargement. And if it's smaller than 1, it's a reduction, because 1 represents 100%. Remember, it does change the shape. It does change the size, but not the shape. Clearly, same shape, different size. So the angles are all preserved, angle measurements, but your sizes are going to get bigger. So if your scale factor is K, then a side AB with length C is going to then be transformed to a side K times C. So that's what a similarity transformation will get for you. So we went over, how you can do an image and a pre-image. Remember, we tell a pre-image because that's the original. That's the one without any quotes or marks. This is where we start. And you would do, when you write them, from left to right, this is your pre-image, this is your image. You can assume that that's how Big Ideas does it as well. Now, we did have a theorem or two in here. We have corresponding lengths. Okay, so if you know that the polygons are similar, then the ratio of any two corresponding lengths is also equal to that scale factor, which means in a problem like this, we can write 20 over A, that's our image over our pre-image, is equal to any one of these parts as well, 8 over 6. And you'll be using that specifically, and that's 8.1. The second part of 8.1 is two theorems, and that has to do with area and perimeter. So if you have a scale factor, then the perimeter ratio is the same. You can just go straight from K to the perimeter, like this example in our notes. However, area is length times width. So this one is very close to it, but remember the area ratio is the scale factor squared. Okay, so your area ratio will be the scale factor squared. It changes just a little bit. That's all you got to remember. Okay, that's 8.1. 8.2, we introduced the angle-angle similarity theorem. And we solved a bunch of real-life problems on here. So angle-angle is a way to prove similarity, which again preserves angle, but it doesn't preserve the size. So you can get that two triangles are similar, okay, which gives you proportional sides, if two of those angles are congruent. That's all of 8.2. It was just the one, we did some problems, and there'll be more like these where you'll get a word problem. You may have to draw a picture. You may get a picture, or they'll be overlapped like this, where if I were you, I would just redraw the smaller one so that you can see those ratios easily. 8.3 going on, again, page 435. It's very much similar to AA, but now you have side-side-side similarity, where you can also use proportional corresponding side lengths. Further, you also now have what we called side-angle side similarity, same type of thing. You can write those ratios if you get that similarity. In the back, we did some real-life examples. Again, parallels, all kinds of things, but very straightforward. We spent one day on that. There was the second day of 8.3, we did some proofs. Okay, we just did those 4 proofs. Color coding. That is my key for you. Color coding super duper helps me. This one was longer and this was like a mini version. You should be able to do either one of them. 8.3. And then last, this should be the freshest in your mind, but it's also the longest. It was 4 different theorems. We have a proportionality theorem. So if you have parallel lines within triangles, okay? So if you have 2 parallel lines in a triangle, then you can write the ratio of their sides, 2 sides, proportionally. So in this case, it's RT, the pink, over RQ, green, equals RU, the pink, over RS, the green. Pink over green equals pink over green. We can solve problems like that. The converse is also true. So if you do have that proportionality statement that is true, then you also have parallel lines. So if this is, you would use in a proof. If you need, to know if you have parallel lines, start with that proportionality. A brief review here on 8.4 was contrapositive and inverse. So you can prove things also with the contrapositive of that first one, and also the inverse of the inverse of the second one. So remember, those are equivalent. Like if it says check if they're parallel, well, you can check if they're parallel by checking if their ratios are equal. So that one we did together clearly. And then 2 more theorems. This 3 parallel lines theorem, I'm going to guarantee you, is on the quiz almost exactly like this example. Okay, so make sure you know how this works. This one says if you have 3 parallel lines that cross 2 transversals. Okay, so this one, I have the transversals in green, the parallels are in pink. If you have this situation, then these 2 parts here on the inside, these are proportional. They're divided proportionally. So you can write some pretty simple proportions if you have this situation. Okay, so 150 over 300 equals 120 over x. It's pretty straightforward. That's how we use that. Last, triangle angle bisector theorem is very similar to this one, only it's, as you can see, triangles. So if you have an angle bisector, then the opposite sides are proportional to the length of the opposite side. So you can write AD over DB. These 2 sides are proportional. It's going to be equal to AC over BC. So green over orange equals green over orange. And then we did 3 different examples on that. Just so you know, technically, you could actually write bottom over side equals bottom over side. So there's more than one way to write the proportion as long as you keep them in proportion. Green over green equals orange over orange. Just as long as you don't swap them. Like you can't do bottom over this equals bottom over that. You can't do that, but you can swap the different colors. If you do better with colors, use them. Nobody's watching. I just want you to do your very best. And so we're going to be doing problems out of the student journal. Again, the answer key is in the content library, chapter 8 folder for every problem. There's 53 total, and we won't be able to do all of them together, but please make sure you ask questions, raise your hand, unmute yourself. I'm right here. I want you to do your very best.